You know how much information you can really I have no idea. I have no idea. But, so, the sample is talking about setting the free again, or oh, I just but also aren't in favor of them. I am part of that.
I see it's 11 o'clock, so we should begin this session. I'm Jim Allen from the University of Michigan, and it's a great honor to be chairing a session that will is devoted to the memory of David Pines. Me personally, this combination of ICAM and David has meant a great deal in equal parts that ICAM with David around offered a kind of access to a higher intellectual level than was common in my life, I would say. And so it's just very meaningful in that particular way. And then also it offered me an opportunity to make real a person who had been a name in terms of having read papers and looked at textbooks. So this combination has been very significant for me personally. It would be appropriate in any physics venue to have such a session as this one. But of course, here at ICAM, it would be a travesty if we did not have such a session. So we have 3 speakers, and there is a little misprint in your schedules. We will actually have all 3 in sequence from the time of 11 o'clock until 12:30, and each speaker will have the full time. And then we'll have an open mic session from 12:30 to 1300, which will fulfill the usual rule about how we distribute the time. So, with no further ado, our first speaker is David Campbell, and I see he has a picture here which I've been sitting here looking at it and thinking to myself, you can almost see the eyes twinkling in that way that we all know. Please, David. Mike.
Let's do it this way. Well, thank you very much, Jim. I'm both pleased and honored to be able to start this session in memory of David Pines. We thank the organizers for planning this. Those of you who knew David will know why I have gone from the standard informal ICAM dress and putting on a profile in honor of David. So this is going to talk about my 5 decades of knowing him and how much he influenced my life and how our science sort of overlapped and what he did in terms of various things. So I'll talk about several overriding themes. The first is the science. David and I never collaborated. My Pines number is 2. I'll back to that later. But we did work on similar problems. We worked on gluons, we worked on neutron stars, and I'll talk a little bit about that. David was famous, as we know in this venue for sure, at building institutions. And I'll talk about several of the institutions we built. All those, you'll see a lot of these, that is definitely not the button you want to put. You'll see a lot of these famous PLAs, three-letter acronyms, all over the place. But I'll explain those if you don't know. I'll talk a little bit about science and diplomacy. The recording that I know Laura's going to say more about that, but I'm going to talk particularly about David's interactions, not just with all the Russians, but with one particular Russian who meant something special to both David and me. And I'll talk a little bit about what he did on education. The red is basically the areas in which David and I directly overlap and work together on various projects. So I'm also going to talk about by the decades and the locations, not just by the science. So Cambridge, 1970, I was a PhD student in Cambridge. We'll hear more about that in a minute. Urbana, where I got my first postdoc, and ultimately a postdoc. Princeton, at the Institute, where I worked on stars, and we had our first scientific overlap, serious one. Then Los Alamos and Santa Fe, where between us, we spent almost the same amount of time in various capacities. I, as a staff member, David as a visitor, staff member, and a key division advisory committee leader. We'll talk about ASCA on numerous happy occasions, including the last time I spoke with David, a 2-hour interview. I hope to have some snips for that. I couldn't get them in August of 2017. Urbana, I came back as the chair, or the head, rather, excuse me, of the department, where I was actually the boss, if you can imagine what that would be. And then Boston and Davis period, I went to be and David to Boston. So that's pretty much it. So let's start with Cambridge. It's a great quote. This is from David's NAS autobiography, which I definitely recommend you all to read. It's available for anybody who can't find it online. I will send you a PDF. It's a beautiful history of his life. And here's his first quote. You see, there were essentially no academic jobs in physics in 1950. So he felt very lucky that he got an offer of an instructorship at that. Well, in 1970, when I graduated from Cambridge, there were no academic jobs in physics. The door had slammed shut. The 3 years before that, people didn't even apply for jobs. They simply had their professors call somebody and say, "I have this bright student, please hire him or her." And they did. I met David when he came to Cambridge in the early 1970s, and we clicked, and he went back to Urbana and managed to cladder together a position for me as a half-time instructor in physics and a half-time fellow for the Center for Advanced Study, which is one of the institutions we built at Illinois. So basically, David was responsible for saving my career in physics. The lesson learned from this is that mentoring matters. Take care of your junior colleagues. Science, let's start with polarons. Our shared interest was separated in time. David's work, of course, David's in the 50s. I'll come back in a second. I did some work in the 80s on this. Amusingly, there's a hidden figure in this story as well. Very well known hidden figure named Lev Landau. Those of you who probably know about polarons know that Landau wrote the first paper on polarons. That coined the Kristallgitter in the Soviet Union. It's a 2-page paper, and I defy anybody to figure out what he was really saying. But he did have the idea that polaron and review would exist. David wrote a couple papers on polarons. Probably his most famous one is the Lilo Pines. We'll come back to that later. About motion of slow electrons in the polar crystal, where they use established variation technique that is still used today. And they famously, I think Gary mentioned this the other day, all their calculations did not involve Feynman diagrams, although they do a lot of them, but they were using canonical transformations, very different kind of technology. Probably my most famous paper on polarons is a general paper on polarons in quasi-one-dimensional systems, which I wrote down with Klaus Spesser 30 years after this. So here's the Lilo Pines paper. You probably can't read this abstract. That's the problem with trying to take it from a tech file. But the important point here is they use a variational technique, and it's using a canonical transformation. They were able to develop a Hamiltonian, and calculate the properties of the small polaron in that motion. This paper, I didn't check how many citations it has, but it must be near 1,000. It's a very important paper in the history of polaron. My paper is not so important, but we actually did some work on models of interest in transport acetylene and others, similar one-dimensional systems, and we showed that two polarons people thought were different actually became identical in the particular limit. Polyacetylene famously expanding around the Fermi surface, you get the quasi-relativistic spectrum, which then the dimerization induces a mass. There are two levels in the gap. The polaron actually has the lower level doubly occupied and the upper level singly occupied, so it's an electron polaron. And there's also a hole polaron, which has almost a single occupancy here. So in the limit that the binding energy gets very small, this reduces to the polaron that Hines and others studied in the one-dimensional case. So that's the area of scientific overlap. So Urbana in '72, as I said, David collaborated together a half-time position in the Center for Advanced Studies for me, and a half-time position in the Department of Physics. David was already working on neutron stars. I was working on high-energy theory. And what was really important was the welcoming nature, and this remains true today of the Urbana Physics Department. It's extremely collegial. And that was started by others as well, but David and Susie Hines kept it up. Very welcoming nature, wonderful dinners at their house, paintings of Ben Shahn and Russian artist Vadim Sador, who will play a role in the later discussion. And the lesson learned here is that collegiality really matters. It makes a big difference in how you feel, particularly junior people feel when coming to a department. And David set the stage for that. Princeton, here, the comments of neutron stars I was working on biocondensation. David was working on star quakes and superfluid fluidity. Serious scientific overlap. We didn't collaborate, but from distance. So here is here's a picture of a neutron star. A neutron star, for those of you who haven't heard about it, is basically a giant nucleus. It's about 10 kilometers across with the mass of the sun. So its average density is 10 to the 14th grams per cubic centimeter, which is the net density of the nucleus. And here, just an example, I won't go into detail, but there are lots of speculations about what the core of the neutron star could be. Here's a pion condensate, here's a core type of star, here's a hyperon star, a strange quark star, quark matter, kaon condensates. David was studying something that's fuzzy in this picture, the very crust, and how the quakes may describe pulsar glitches. I was working on a model for pion condensation inside the star. This is a great story. Lev Landau again, big, enormous influence. Landau actually first thought of the concept of neutron stars, which he called unheimliche Sterne. And the story that I always heard was that he heard about Chadwick's discovery of the neutron in '32, and then immediately projection of neutron stars. It turns out that's another bit of folklore that isn't true. There's a nice article by Gordon Bay and Chris Pethick et al. In the archive, and you can see what's happened here. Briefly, to read the discussion, the story was originally that Landau developed the idea of neutron stars in discussion with Bohr and Rosenfeld. Landau was quick, but not that quick, no doubt. They found out that actually Landau had a paper that was written in March 31, but not published until February 32, in which he speculated on the existence of stars that looked like one giant nucleus. So they wouldn't necessarily be pure neutrons, but they would be like a giant nucleus with more neutrons than protons. And the fact that this myth became the story of Landau's embedding it immediately is not surprising, but it isn't true. But still, Landau did have the first concept of neutron stars. David's earliest paper was with Gordon Day and Chris Pethick about superfluidity in neutron stars. And it's interesting, David, many of you may have heard his colloquium about superconductivity from BCS to neutron stars. It was a wonderful talk in which he talked about superconductivity and superfluidity. I think it was Laura who mentioned that none of us could cover even a billionth of what David had done in science. and that's certainly true here. He published 33 papers on neutron stars, with topics ranging from superfluidity, to glitches in pulsar emission rates, to quakes, vortex creep. But one thing that I found particularly interesting in reviewing this was that in the light of what I will call their discussion over the mechanisms of pi 2c, I assume all of you know about that. David and Phil Anderson, it's amusing to see that he published some papers with Phil on the front stars. So I'll use a technique we use in lectures. I'm sure you're all paying attention. Turn to your neighbor, and what do you notice about these 4 papers? What about the authors?
On the outdoor.
Now, the author is certainly not an author, but what the Pines and Anderson are working together on these papers. They're both authors, they're co-authors, okay? So what the lesson from this is the Pines and Anderson are collaborating, and this is a lesson that friends can disagree on problems and agree on others, but it's not about physics, it's about the physics, not the personalities. So this, I like this part of the story very much. Here's a picture. David, this is Jakob Shaham, who unfortunately died very young. There's Phil, and that's Alice. This is in Urbana at a conference in 1981. So I'll talk a little bit more about the work on pi and condensation. The idea is pretty simple. Certain levels of neutrons and protons in a neutron star, because of high density, are so much higher than temperature, you treat it as if it's a zero temperature on it, believe it or not. And what happens if the chemical potential of neutrons exceeds that of the protons by more than the mass of a pion? Well, what happens is, in a non-interacting theory, a neutron can change into a proton and a pi minus, and the pions will both condense. So that is a pion condensate in the very simplest model. It turns out, though, that the pion-neutron reaction is very strongly attracting in the P wave. This is the famous delta resonance that Fermi discovered in the early resonance scattering. And so the pion condensate is actually expected to be in a non-zero member state, which gives you an exotic superfluid superconducting state. This was first proposed in 73 by Bigdahl, but also by Sawyer, Scalapino, and Graham at about the same time. So pion condensate in the neutron star. I worked on that. This actually led me to a connection to A.B. Bigdahl. We'll come back to that. These are my papers. I don't want to go into detail on it, but it was we were able to show with Roger attachment that some of these results on pi condensation were independent of the details of the interaction and dependent only on the general nature of chiral symmetry at sort of, if you will, universality in this case. So as I said, my publications with Gordon give me a Hines number of 2. Here's Phil Anderson's work on pi and condensation that's independent of his work on neutron stars with David. And all of you probably know, remember, that in the famous gravitational wave incident in August of 2017, that was the first gravitational wave event that was observed by non-gravitational means, because it involved the class of 2 neutron stars, which produced a kilonova, which is about 1,000 times brighter than a normal nova. And this is by the so-called Bar process, the source of 50% of the heavy elements beyond iron in the universe, including things like the gold in our wedding rings. So let me see if I can make this thing work. Show you. Oh, it didn't sound. I lied. I know, there should be a button, but it never. So this is a picture of 2 neutron stars rotating, coming together. music. That's actually all right. So next, third topic is institution building. David Urbana was conceived of and built many institutional research efforts. This thing called the Center for Advanced Study, which I've already mentioned. Thank you, Jim. So David conceived of these things. You probably heard me talking about them, but he's right for recording purposes. The Center for Advanced Study was his idea. He was the founding director. He built a research group with Ron Stars. Besides his first David was with Gordon, Chris Pethick, Fred Lamb, Dr. Shaham, came along. This is very interesting. This is not a well-known story. David put together a proposal with the IC College, UC College, to have an Institute for Theoretical Physics be in Urbana. But he was smart enough to realize that in terms of location, Urbana could not compete with Santa Barbara, given the summers and the winters. So he had a network institution, a distributed network, both based in Urbana, but local. And this is, in fact, in my view, an idea we should put all the way through the ICAM. And of course, starting in '86, he helped build a high-QC group with many colleagues. The lesson learned here is if you build it, they will come. And David certainly was. These are nice memories of Urbana. The picture's pretty dark. Those of you who know them will see David here, sitting next to Gordon Bain. There's Tom Stronghold up there. This is actually a very later moment. It's in the 80s. These are gentlemen I assume you recognize. David conversing with Marie Gilman. This Centennial Colloquium series actually, well, if you stress it, is another thing that David did while he was in Urbana. This is a nice picture showing David sitting in the front row with John Bardeen and Charles Sister. And again, those of you who know Gordon Bain, he's in the back row calculating probably some alternative as well. In terms of building institutions in Los Alamos and Santa Fe, run down this list of things. David was involved in Los Alamos from 73 to 97, a member of here's another one of our famous three-letter acronyms, the Key Division Advisory Committee. Oh yeah, that's right. Staff member, he was visiting scholar. He held this Ulam Scholar position at the Center for Nonlinear Studies, and he was, of course, famously a co-founder of the Santa Fe Institute, which also was part of the origins, during that time, part of the origins of ICAM-NCTS. I was also at Los Alamos during this period. Here's the shared comment. I was a Ulam scholar 2 years after David was. Should I finish on time? So the lesson we learned again is if you build it, they will come. This is a picture of the Santa Fe Institute, the so-called three Davids. Here's David Pines in the middle, David Gross here, and there I am. This is a science board meeting in about 2012. Science is diplomacy. I want to focus here on one individual named Kaja Rigdal. As I said, I'm going to put Laura as focus. She will focus more on that. So our colleague named Mr. Rigdal, known as Kaja, was, as many of you may know, a very famous and remarkable Russian who actually just barely missed the theory of superconductivity and made many other contributions. This is David's comment about how he first met Rigdal. It's a long thing. The key points are, he was in Copenhagen. He met Spartak Belyaev, who was a student of Rigdal. He was considered one of Landau's most brilliant students. David met Rigdal later and immediately liked him. He had an abundance of charm, which is absolutely true. Rigdal had many interests, jewelry making. He was a sculptor, he was a mountain climber. He actually was the first person in Russia to introduce scuba diving. He manufactured the parts himself in the grass at the Kirchhoff Institute and smuggled them out of the institute. And this is from the autobiography. So I met Rigdal from our shared inspiring conversation when I was actually invited as a guest of the National Academy to visit Russia and the Soviet Union in November. Given the time, I won't go into this. I have some absolutely wonderful memories of this trip. Rigdal was connected with many artists and musicians. Again, let me just mention one. Rigdal gave me a small icon, not a painting, but a metal icon. and I was taking it out of Mossville in my suitcase, very heavy suitcase, and the Russians had finally gotten X-ray detectors. So it was clear this metal icon, which was not legal to talk about, would be detected. So I walk up there, and there's a woman in charge, and a man looking at the suitcase up, and I hand her my papers, and he says, "Tovarищ, это Academia now." Comrade, it's the Academy of Sciences. So they didn't put my bag in the machine, and I got out with the bag. I hosted Miguel and Goliath in Los Alamos in '78. I must tell this story. Miguel, as you saw, was a very charming man. We went to an old ruin known as Tottican on the north rim of the Grand Canyon, Anasazi Indian ruin. And we were walking on the trail, and suddenly this Texan wearing a yellow hat comes up and says, "Howdy!" And he taps me on the shoulder. He says, "What did I say?" I said, "It's howdy. It's short for how do you do." So we're walking on the road, another group comes up to us, and Rico shouts out, "Howdy!" Perfectly. So here he is, Miguel with David, and this is Henry Bohr, shortly before he died. He died in 91. Finally, with education, David's role in enhancing education in physics and science in general spanned most of his career. He was famous for starting his frontiers of physics and served as its editor for almost 40 years. This idea was to bring the latest developments to young researchers in an understandable manner so that they could follow them easily. Famously, he was also the editor of News of Modern Physics. In Aspen in 2004, Liz Simmons and I put together a workshop on science education, and David played a very active role in that, and that stimulated his interest in bringing science to the public. He interacted with one of the museum directors there, and that got him really going in that. We're going to hear more about his global partnership for science, the GSEE, his co-founding chair, ICAM-NCTS initiatives, and just think like a scientist initiative. So David played a tremendous role in educating junior colleges. For that, in 2015, he was awarded the AAPT's J.D. Jackson Award, and here's a picture of him receiving the award in New Orleans, I believe. So that's it. Moveable feats of the line, 5 decades with David. There he is in black and white. Here he is in color. And thanks to David for all the happy memories, and thank you all for your kind attention. So I think I've used up all my 30 minutes, so we take time for questions later. Yeah, I think that's right. Okay. So, you're up next.
Okay.